The 2018 FAA reauthorization bill mandated that the agency no longer require the use of aqueous film-forming foam, or AFFF, for firefighting due to health and environmental concerns. Since then, the FAA has worked with the Naval Sea Systems Command to test and develop a new fluorine-free firefighting foam, referred to as F3. The first F3 product was approved by the Navy in September 2023. Subsequently, the FAA released National Certification Alert 23-07 to let Part 139 airports know that F3 is now on the Navy's qualified products list and they can begin using F3 in place of AFFF. The FAA also updated and published Advisory Circular 150-5210-6E, Aircraft Fire Extinguishing Agents for Airports. It is critical that airport fire departments fully understand the differences between AFFF and F3. While both foams are very effective, training must be adjusted to emphasize the differences in F3 performance in extinguishing Class B liquid fuel spill fires. AFFF extinguishes fuel spill fires in three ways. The foam blanket suppresses the combustible fuel vapors, the water cools the fire, and the fluorinated surfactant drains from the foam bubbles and creates a film between the foam and fuel layers. This film helps the foam blanket travel across the fuel spill and reseal itself when the foam blanket has been broken. Even when the foam blanket has degraded, the film from the fluorinated surfactant continues to provide vapor suppression. F3 differs in that it lacks the fluorinated surfactant and doesn't have the film-forming properties of AFFF. As a result, F3 suppresses the fire in only two ways, by suppressing the vapors with the foam blanket and cooling it with water. Without the film formation, maintaining the foam blanket becomes the critical aspect to the success of the fire suppression. Firefighters should review basic foam application and accepted methods of applying foam, since one of the most common failures in foam performance is human error. If users fail to apply proper foam operations, techniques, methods, or management, this can cause the foam blanket to break up and allow fuel vapors to reignite. Using AFFF is more forgiving, as incorrect application does not always limit its effectiveness. This is because the fire-suppressing characteristics of AFFF often compensate for poor technique. F3 works well in aircraft rescue and firefighting with the proper application techniques, but requires a more precise and controlled approach. This plays a significant role in the effectiveness of F3. Forceful application, such as plunging or rapid sweeping, can disrupt the foam blanket, leading to continued burning or ignition of the foam itself. Standard hose lines and nozzles are compatible with F3, except for smoothbore nozzles. Using variable stream and low expansion nozzles are recommended because they offer the best range and control, essential for effective application. Using a 15-degree fog pattern creates a stream that is the best balance of reach and aeration when using hand lines to quickly knock down and control the fire. This method will also increase aeration in turret nozzles, but with the increased flow rates, throw distances, and distance to the fire, it is less critical in truck-based mass application on the initial fire attack. The goal remains the same: establish and maintain evacuation paths while separating the fire from the fuselage. It's crucial to establish a robust foam blanket for effective protection. The primary and most effective application technique is the base sweep, consisting of slow, controlled overlapping sweeps or passes directed at the base of the fire from a near horizontal stream. It is critical to ensure the stream is maintained at or near horizontal for a gentle application and to avoid plunging into pooled fuel. Each sweep should partially overlap the previous so that the blanket is fortified while progressing the leading edge of the foam blanket. The speed of each sweep is critical. If sweeping is too fast, not enough agent is applied where it's needed and will not effectively extinguish any fire. If too slow, any forward progress may be lost due to fire impingement. Other techniques can also be used for effective foam application. The roll-on technique involves establishing a blanket outside of the spill or fire area and then rolling the foam blanket over the spill or fire. This is only effective on hard surfaces outside of the spill or fire area, because it further aerates the foam without picking up any fuel. Once a blanket has been established, the firefighter will use the discharge to roll or push the foam blanket across the fuel. Another technique is bank down, which requires a vertical surface to deflect the foam stream onto the fuel or fire in confined spaces, or when direct access to the fuel or fire is limited because of debris. The deflected stream is gently applied to the fire or existing foam blanket, but it can be hard to direct to the desired area. The deflection also further aerates the foam. Rain down technique discharges the foam at a high arcing angle, essentially raining down in a near vertical path, to establish or fortify the foam blanket. It is not ideal for initial fire attacks because the thermal plumes can destroy or disperse the foam, preventing it from reaching the base of the fire and the fuel. Rain down can also be affected by high winds due to the small droplets. A rain down technique should follow the initial fire attack after the thermal plume has been knocked down. Plunging is a downward angled discharge that forcefully pushes the foam into the pooled fuel. Plunging can occur during base sweep application as the nozzle passes in front of the firefighter. The natural sweeping motion wants to push the nozzle downward. This can mix the foam and the fuel, causing the blanket itself to burn, or can punch holes in the foam blanket that releases fuel vapor, potentially resulting in flare-ups or reignition of the fire. Additionally, this can spread fuel to non-desired areas. Always discharge onto the fuel and never into the fuel. No one technique may single-handedly accomplish all goals on the incident scene. Base sweep application is generally recommended for the initial fire attack, and roll-on technique can also be considered for an initial attack if the conditions are correct. As the fire progresses, other techniques may be required to fully extinguish the fire. If small spot fires appear in the middle of the foam blanket, use the rain down technique to extinguish them and fortify the blanket. Fires inside piles of debris will most likely require the use of the bank down method to deflect the foam into the debris pile, where direct application is not possible. Firefighters must be aware of the foam blanket's condition at all times. Disruptions, such as those caused by fire hoses being pulled through the foam, crew movement, or passengers traversing the area, can disturb the foam blanket. F3 does not reseal itself as AFFF does. Rain, wind, and weather can also affect the foam blanket and nozzle discharge by moving the foam blanket or parts of it and creating openings for fuel vapors. Debris can cause the foam blanket to break down more rapidly, and hot objects can ignite vapors around them. Reapplication of foam and constant monitoring is essential to maintain the integrity of the foam blanket and suppress vapors. If staffing allows, use a backup firefighter, spotter, or the vehicle driver/operator for surveillance of the area to watch for reflash. Seams where multiple blankets converge will be the weak spots in the overall coverage. Additional foam application in these areas will strengthen the blanket's integrity. Conducting your training with F3 at specialized facilities is highly recommended, as it helps firefighters familiarize themselves with the unique properties and application techniques of F3. When transitioning from AFFF to F3 foam, it is crucial to start with early planning and assemble a skilled team of senior airport staff, environmental agencies, and vehicle and foam manufacturers. As part of your transition planning, it is important to remember that F3 foam cannot be mixed with any other foam or F3 product in the vehicle's foam tank or in storage, because there is no product compatibility. Also, F3 cannot be used as a premixed water and foam solution in a single tank. Begin by coordinating with state and airport environmental officials to ensure compliance with regulations. Collaboration with vehicle manufacturers, service providers, and foam manufacturers is essential to ensure your equipment is capable of operating at its optimal performance when using F3. Airports need to ensure they have adequate storage for the removal of AFFF from the vehicle and any rinsate created when rinsing and/or cleaning the vehicle's foam system, and should maintain separate storage locations for AFFF and F3 to prevent the possibility of inadvertently mixing foams. When preparing the foam tank for F3, ensure the tank is rinsed in a protected area, removing all old concentrate to prevent contamination. This includes rinsing the plumbing beyond the foam tank valve and proportioner, checking all gaskets, and finally, ensuring the entire system is dry before refilling it with F3. Keeping foam tanks full to reduce air gaps helps to prevent oxidation of the foam. Although all F3 products on the Navy's qualified products list have passed the same performance qualification testing, F3 products from different manufacturers cannot be mixed in vehicle foam tanks, as they are not compatible with each other and can have different viscosities. Stick with one manufacturer's F3 products. Changing viscosities requires modifying mechanical systems, as discussed in the next section. Proper proportioning of F3 foam is critical. Conduct output proportioning tests using a refractometer or conductivity meter, followed by recalibration of your input-based systems for F3. Consult with your vehicle manufacturer for the proper procedures and equipment needed to ensure aircraft rescue and firefighting vehicles are proportioning foam at 3%. Conduct foam testing as described in the National Fire Protection Association's 460 Standard, Chapter 29. Electronic systems should adapt to the new foam type without needing maintenance, but it is still recommended to do output tests. Older mechanical systems may require modification, such as increased orifice size, to achieve proper proportioning with F3. All systems should be checked for proper proportioning using output-based tests following F3 conversion. Consult your vehicle manufacturer prior to transitioning to F3 in foam testing for a seamless transition. F3 represents a significant shift in firefighting strategies. Its effectiveness hinges on the correct application, vigilant monitoring of the foam blanket, thorough training, and preparedness. By mastering these new techniques and understanding F3's unique properties, firefighters will maintain high standards of safety and effectiveness in their critical response operations.